Welcome to the beginning of Unit 3, everyone. So at this point, you guys would have just, I don't know why I can't get rid of that right now. Anyway, you would have just looked at a warm-up beginning that is the intro to the units. You got to see a fun picture of one of my former students who turned her eyebrows into something called a cube root function. But before we can learn about all these roots and radicals expressions, we need to learn how to manipulate them, which involves some basic properties of exponents we have to review. You also would have just finished sharing out some observations that you remembered from Algebra 1, looking at the pretest about those properties of exponents. So on this handout right here, what you guys are going to do is examine each of the 7 properties with a partner and make sure you understand how they work. So there's an example and the explanation is already written out for you. So your job is just to make sure that that makes sense to you. Okay, I'm going to hit pause. You guys are going to look over those for a couple of minutes, and then we're just going to share out and make sure that we all as a class understand each property. Okay. So looking at the first property, for some reason the multiplication dot turned to a square here. I'm not quite sure exactly why that happened. But this is saying if I have a to the m times a to the n, that'll equal a to the m plus n. The key thing in this first property is that when you're multiplying, in order for the property to work, those bases must be the same. So those are both a's, and as long as the bases are the same, when they're being multiplied, you get to add their exponents. The base does not change. So there's an example of that down here. 5x cubed times 2x to the 5th times x to the 9th. The 5 and the 2, okay, think of those like coefficients. You can just multiply those like normal. 5 times 2 is 10. And then the x's, you're adding up all those exponents. So 3 plus 5 plus 9 gives us a total of 17 x's. The second property, I'm going to actually do this one a little bit differently than the way the property works. It says when you're dividing the same base, you get to subtract the exponents. So a to the m divided by a to the n becomes a to the m minus n. You subtract. The way I actually have students do this property is instead of subtracting, because sometimes when you subtract you get a negative, I have students do the canceling strategy. So if we look at this example, 9x cubed over 27x to the 7th, for the canceling strategy, I have 3 x's up top, an x cubed, and I have 7 on the bottom. So the 3 up top would cancel because 3 is smaller than 7. But if you cancel out 3 up top, you have to cancel out 3 of the 7 in the bottom, leaving you with 4. By doing it this way, you avoid a negative exponent. Because if you do 3 minus 7, you would get negative 4, which would require further work once we review the negative exponent property. And then the 9 over 27, okay, that coefficient there, you can divide those both by 9, and 9/27 simplifies to 1/3. So we get 1 over 3x to the 4th. The third property is power to a power. When an exponent is raised to another exponent, you multiply those two together. So a to the m to the n becomes a to the m times n. There's an example of that. The fourth property and the fifth property go together. And these are important to note that it only works when the bases are either being multiplied like in number 4 or divided in number 5. You cannot do these properties when bases are added or subtracted. So for number 4, we have a times b to the m. Because a and b are multiplied, you are allowed to distribute the exponent individually to both. There's an example of that. And then in number 5, the a and the b are being divided and all raised to the m, and you are allowed to again distribute the m to both. So it becomes a to the m over b to the m. And there's an example of that. So these properties do not work with addition or subtraction. And the best way I can relate to that is earlier we've talked about how to do things like x plus 7 squared. This does not equal x squared plus 7 squared. That would eliminate a whole term in this example. So you would actually have to do x plus 7 times another x plus 7 and distribute it out. This is a very common mistake. There's a lot of things in math that you can do with multiplication and division that you can't do with adding and subtracting. Same thing with radicals when we did the quadratic unit. When radicals are being multiplied, you can combine them, but if they're added or subtracted, they have to be like radicals in order to combine them. The next property, number 6, is how to get rid of a negative exponent. So our final answers will not have negative exponents in them, and you simply move it to the denominator. So a to the negative m becomes 1 over a to the positive m. If the negative was in the denominator, you move it to the numerator. And after I go over number 7, I'll explain why these two properties make sense. And then so if you look at this example right here, we left the 2 alone. The 2 stays where it is because the 2 technically has a positive 1 exponent. The x to the negative 6 moved down to the bottom, and the y to the negative 3rd moved up to the top. Once you move them, the exponents become positive. And the last property is the 0 property. Any base raised to the 0 power will always equal 1. So this whole expression here in this example is being raised to the 0 power, so it all becomes 1. Now the reason these last two examples work, I'm just going to pull up a blank sheet here and show you. I'm just going to pick a random number. I'm going to pick 2. It's a nice easy base to work with, and I'll show you the pattern. So I'm going to take 2 and raise it to different powers. Okay, I'm just going to go up to 2 to the 4th. And then write the result down below. So 2 to the 1st power is 2. 2 to the 2nd power is 4. 2 to the 3rd power, which is 2 times 2 times 2, is 8. 2 to the 4th power will be 16. So as you're looking from left to right, what's happening with these values right here? Once you guys think about that, you can hit pause. And what's happening is we are multiplying by 2. Every single time as I go this direction. So let's continue that pattern backwards. So if I wanted to do 2 to the 0, 2 to the negative 1st, 2 to the negative 2nd, instead of multiplying by 2 like we did to the right, if I want to go to the left, we're going to have to divide by 2 each time. So if I take this 2 right here and I divide it by 2, I'm going to get 1. If I take the 1 and divide it by 2, I'm going to get a half. If I take the half and I divide that by 2 again, if you split a half in half, you're going to get a quarter. Okay. So if we just analyze these 3 that we just wrote, you'll see 2 to the 0 is equal to 1. 2 to the negative 1, the 2 moved down to the denominator and became 2 to the positive 1. 2 to the negative 2nd, the 2 to the 2nd would have moved to the bottom, meaning 2 squared is 4, you would get 1 over 4. So this is just kind of a visual to show where that pattern is coming from and why it'll work with any base. I could do this with any base, including a variable if I wanted to. It would work every single time. So we're going to do just 2 examples together, and then you guys are going to have time to start your homework in class. But before we do that, I just want to emphasize the order in which we're going to use these properties, because most of the problems we're going to do are going to be complex. It's not just one of the 7 properties, but you're going to have to use multiple of the 7 properties. So these are the steps. Simplifying exponential expressions. Oops. Actually, I'm just going to just say simplifying using the properties of exponents. Because they're not technically exponential expressions. If they were exponential, that means the x is in the exponent. So that was bad word usage on my part. So the first thing you're going to do is you're going to do any distributing. So you're going to look to see if there's any exponents that you can distribute to all of your bases as long as the bases are being multiplied or divided. You can't always do step one. Sometimes you don't have to distribute. Second step, you're going to move anything that has a negative exponent. So if it's a negative exponent in the numerator, move it to the bottom. If it's in the denominator, move it to the top. Third step, we're going to simplify across. So we're going to look at our problem and go across from left to right by taking anything with the same base and adding those exponents. So that's using property number 1. Okay, if you want to make that note, that's using property number 1. And then, for example, or step 4, we're going to go ahead and simplify in a downward direction, and we're going to do any canceling that we can. And that's using property number 2. If you follow these 4 steps every time, then your final answer will be simplified at the end. This is not the only way you can get the correct answer, but it's just the way that I teach it. So that way it's more strategic and you're doing the same sort of thing over and over and over again and you get used to it. But there are multiple ways that you can arrive at the same outcome. So we're going to start off with 2 examples. And the first one is going to look crazy. I figured I'd throw a long one at you right away where we can apply all the properties. And then after we do this one, the other one should seem a lot easier. So I'm going to give you a big set of parentheses, and we're going to have a fraction in here. 4x squared y to the negative first over 6xy. All of that is to the negative second power, which is going to be multiplied by y to the fourth over x to the sixth y squared. We're going to go step by step and work through this. So step 1 was to do any distributing. So we're going to go ahead and distribute the negative 2 to all of the bases in the parentheses. That'll give us 4 to the negative second. Now, when I distribute the negative 2 to the x already had an exponent. So we have to use our power to a power rule. We're going to do 2 times negative 2, and that's going to become negative 4. Same thing with the y. The y already has this negative 1. So negative 1 times negative 2 becomes positive 2. And then we also distribute it to everything in the denominator, giving us 6 to the negative second, x to the negative second, and y to the negative second. In a problem where you have 2 separate fractions, you can really just turn it into one big fraction where everything in the numerator is being multiplied and everything in the denominator is being multiplied. So I can just multiply by that y to the fourth up top and the x to the sixth, y to the second on the bottom. So I just brought it into the other fraction. So step 1's done. I distributed. If we refer to the process, step 2 is move anything with a negative exponent. So everything I'm about to circle is going to move. Everything I don't circle is going to stay exactly where it is. Okay, so those are going to move, they're going to flip, and everything else stays. So coming up to the top, I'm going to have a 6 squared. I'm going to write that first because normally numbers are written in the front. And then I'm bringing up an x squared and a y squared to the top. And I already had a y squared and a y to the fourth up top, which you could have combined in that last step, or we can combine later. Okay, so the first 3 are what we brought up, and the last 2 are what were already there. In the denominator, we're bringing down a 4 squared and an x squared, not an x squared, excuse me, an x to the fourth. Sorry about that. 4 squared and x to the fourth. And we already have an x to the sixth and a y to the second. So step 2 is done. We moved the negative exponent. Step 3 is to simplify across. So we're looking for same bases that we can combine. Also at this point in time, because if we look at the numbers, these bases are different, I'm going to do out the powers. So 6 squared is going to become 36. There's no other x's up top, so it stays x squared. And if I add all the exponents of the y, I get 8y's. In the bottom, 4 squared is 16. I combine my x's by adding the exponents to get x to the 10th and y to the second. Step 3 is done. The final step is going to be to simplify in a downward direction and cancel out anything I can. The 36 over 16, they don't have an exponent, so you can treat them like a normal fraction, and we're going to divide those both by 4. Okay, 4 is the common factor of both. 36 divided by 4 is 9, and 16 divided by 4 is 4, so it becomes 9/4. When I look at the x's, I have 2 up top, 10 on the bottom. The 2 up top are gone, and the 10 on the bottom becomes 8. And always ask yourself, where are they? Those x's are in the denominator, not in the numerator. The ones in the numerator canceled. Same thing with the y's. Y to the second, all those y's are going to cancel, leaving you with 6, and those y's are in the numerator. And that is our final solution. Can't be simplified any further. Okay. One more example. This one's not going to be nearly as long. And the reason why I'm doing this is because sometimes these properties can be more confusing when you're using them with number bases versus variable bases. So we're going to have -3 to the 4th times -3 to the 5th over -3 to the 12th. The only reason those negatives are, or the parentheses are there, is because of the negatives, to show that the negative is also being raised to part of the power. They're not there to indicate distributing, because there's nothing to distribute here. So we can't do step 1. There's nothing to distribute. Step 2 says move negative exponents. There are no negative exponents. There are negative bases, but we don't move negative bases, just the exponents. So step 3 says simplify across. Well, -3 to the 4th times -3 to the 5th, those are the same base. I can use that property. That's going to become -3 to the 9th. Notice the base did not change. You don't actually multiply -3 times -3. You're trying to see how many -3s you have. You have a total of 9 now. Over -3 to the 12th. Now we're going to use step 4, dividing, same base. These are both the same base, so we can do the cancel method. The 9 -3s in the top are going to cancel, leaving you with 3 in the denominator. When the whole numerator cancels, it becomes a 1, and then we have -3 to the 3rd. We would then do out that power. When a power is odd, it's going to stay a negative answer. If the power was even and there were parentheses, it would turn into a positive answer. So -3 times -3 times -3 is -27. And you can choose to either leave the negative in the denominator, move it to the center, or move it to the numerator. So the remainder of class, like I said, you guys are going to work on your homework, practicing these. They are going to get a little bit more challenging. You're going to see that I'm trying to take these basic Algebra 1 exponent properties and try to have you guys apply them to more Algebra 2-like expressions. You'll definitely see that as part of your homework when you see some SAT-like examples. Remember, with those, you got to show your work, write a sentence, one or the other. You got to show where it's coming from. So try really hard, especially when they get more Algebra 2-like and less Algebra 1-like, and then you guys can check your answers tomorrow to see how you did. Have a good night. Have a good rest of your day.